Imagine a star so hot that it makes our sun look like a flickering candle. We're talking about a cosmic inferno, a stellar beast blazing with temperatures you can't even begin to imagine. Today, we're diving deep into the fiery heart of the universe to explore the hottest star we know of. To understand just how extreme this star is, let's first zoom in on our sun. It's hot, really hot. The sun's surface temperature sits at around 5,500 degrees Celsius. But deep inside, at its core, it burns at a staggering 15 million degrees. And that's already mind-bogglingly intense. But the star we're talking about today puts our sun to shame. This star's name, Wolf-Rayet 102. It's a type of star known as a Wolf-Rayet star, and it's turning up the heat to a whole new level. Wolf-Rayet stars are the rock stars of the universe. They're massive, burning through their fuel at a blistering pace, blasting out strong winds of charged particles and shining thousands of times brighter than our sun. And they're hot, like really hot. The hottest known star in the universe, Wolf-Rayet 102, has a surface temperature of about 210,000 degrees Celsius, or possibly even hotter, with some estimates suggesting it could reach up to 250,000 degrees Celsius. Let that sink in for a second. 250,000 degrees. That's nearly 50 times hotter than the sun's surface. Now you might be wondering, why are Wolf-Rayet stars like WR102 so insanely hot? Well, it all comes down to their size and life stage. These stars are nearing the end of their lives, having already burned through their hydrogen fuel. What remains is a core burning helium and heavier elements at extreme temperatures. They've shed their outer layers, exposing their scorching hot cores. And they're not just burning bright, they're burning out fast. Wolf-Rayet stars live for a short time, mere millions of years, compared to the billions our sun has. It's like a cosmic sprint. They shine intensely, but quickly exhaust their fuel. But how do these stars compare to other hot stars, like blue giants? Blue giants, which can reach surface temperatures of about 20,000 to 50,000 degrees Celsius, are certainly hot. However, Wolf-Rayet stars, like WR102, far exceed these temperatures, sometimes reaching 4 to 5 times hotter. The reason? Blue giants are still in the main sequence phase of their lives, burning hydrogen. Meanwhile, Wolf-Rayet stars have moved on to burning heavier elements, which results in far greater temperatures. But let's imagine something wild for a moment. What if we replaced our sun with Wolf-Rayet 102? Would Earth survive? Not even close. The immense heat and radiation of WR102 would spell doom for life as we know it. To have the same level of warmth that we currently get from our sun, Earth would need to be incredibly far away. In fact, Earth would have to be located about 1,000 times farther from WR102, roughly 150 billion kilometers away, far beyond the orbit of Pluto. Any closer, and our planet would be scorched to a crisp. Even at that extreme distance, the intense radiation would likely strip away Earth's atmosphere, leaving it barren and lifeless. It's safe to say that Wolf-Rayet 102 is not the kind of neighbour you'd want in our solar system. So what happens when a star like WR102 has finally burned through everything it's got? Well, it's in for a spectacular and violent end, a supernova explosion. When it happens, it will release an immense amount of energy, outshining entire galaxies for a brief moment and scattering elements across the cosmos. And in some cases, the core that remains can collapse into one of the universe's most mysterious objects, a black hole. But is WR102 really the hottest star out there? Or is it just the hottest we know of? The universe is vast and filled with mysteries. There could be other stars out there burning even hotter, just waiting to be discovered. Some scientists speculate that hypothetical stars, like quark stars or pre-hypernova stars, might reach temperatures beyond even the hottest Wolf-Rayet stars, possibly in the range of 300,000 to 400,000 degrees Celsius. However, these objects are still theoretical and haven't been observed. There's also the question of whether any stars have burned hotter in the distant past, during the early stages of the universe. The first stars, known as Population 3 stars, could have reached incredible temperatures before they exploded into supernovae, leaving us only with clues. The existence of stars like WR102 reminds us of the incredible diversity of the cosmos. There are stars colder than ice, stars blazing hotter than anything we can fathom, and everything in between. They're the engines of the universe, forging elements and shaping the fabric of reality itself. So, the next time you look up at the sky, remember that somewhere out there, stars like Wolf-Rayet 102 are burning in ways that defy what we experience on Earth. They live fast, burn bright, and go out with a cosmic bang. And while they may not be ideal replacements for our Sun, they serve as a reminder of just how wild and varied our universe truly is.